We're going to talk for a minute about gas density. We have a very convenient formula for calculating gas density. And that formula is the density of the gas equals the pressure times the molecular weight over RT. This is a formula that's been derived from three other formulas you know. Grams equals moles times molecular weight. Density equals mass over volume, and PV equals nRT. Just rather than grams equals moles times molecular weight, that can also be thought of where moles is N and grams is mass. Solving these three together, we end up with D equals P times molecular weight over RT. Like PV equals nRT, the units that we're plugging into this formula matters. Since it's derived from the ideal gas law, the pressure that we're going to use is going to be ATM. MW is the molecular weight, but you need to remember to be careful of diatomics. R is the same gas constant as it's always been, so 0.0821, and T is the temperature in Kelvin. Gases are much less dense than liquids. So with liquids and solids, we had density in units of grams per milliliter because we get a measurable mass out of something this small. But since gases are so much less dense, we need a much bigger volume to have something measurable. And the density is going to be in the units of grams per liter. So let's take a look at a sample problem. We're going to find the density of nitrogen at 770 millimeters of mercury and 25 degrees Celsius. So remember, millimeters of mercury is the same thing as torr. So my pressure is 775. Is that in the right units that it's supposed to be in? No, I'm going to need to convert it to ATM. So 775 over the unknown ATM temperature is equal to 760 over 1. And converting 775 divided by 760 gives me 1.02 ATM. Okay, we are talking about nitrogen. Is nitrogen diatomic? It sure is. It's N2, so my molecular weight I'm going to be using is the weight of 2 nitrogens, which is 28. I've also given you temperature here. Temperature right there is in Celsius, and it's going to need to be converted to Kelvin. So we're going to add 273 to it, and we have 298 Kelvin. Now I have everything I need to plug into the formula. So now D equals P times the molecular weight over RT. The pressure is 1.02. The molecular weight is 28. R is 0.0821. Temperature is 298 Kelvin. 1.02 times 28 divided by 0.0821 and divided by 298 gives me an answer of 1.17 for the density. And density from this formula is in the units of grams per liter. Okay, we have 2 problems for you to try.